Hello and welcome to Monash University. My name is Michael Morgan and I'm the coordinator of the Coursework Masters programs in the School of Physics and Astronomy. In this short video I want to give you some background on the MSc in Physics and give you some information that might help you decide on whether this is the appropriate program for you. You'll notice the slides contain information that will allow you to contact me and other people within the school and university. So please don't hesitate to use my email address if you want to ask further questions. Let me begin by posing a question to you. Why would you choose this course? Well, there are many reasons, but let me try to succinctly summarize the main reason. The specialist degree, the Master of Science with a specialist in physics, provides high-level training and the research skills which are necessary in which to navigate a complex and increasingly technological world. So these skills are highly valued by industry, and I'll say a little bit more about careers towards the end of this video. A more pertinent question might be, well, why choose Monash University? Well, when you join Monash, you will be joining a world-class university and will have access to significant facilities. Let me emphasize that one measure of the research intensity of a university is how it's judged internationally. And the School of Physics and Astronomy at Monash University is ranked in the top 100 physics and astronomy departments in the world. And this ranking is based on all major rankings, such as the academic ranking of world universities, the QS and the Times. Another measure of research intensity is what we call ERA. This is an audit of research excellence that the national government in Australia carries out. And in the last audit in 2018, the School of Physics and Astronomy was ranked 5, which is the highest ranking, well above world standard, in all its research programs. It received an overall rating of 5 and also the highest rating for the impact of our research. This places the school among a very small number of universities in Australia with this kind of research intensity. Let's talk briefly about the entry requirements. There are 2 ways of approaching the program. If you have a 3 or 4 year undergraduate degree, you can enter at level 1, in which case the program is 2 years full-time or 4 years part-time. You're required to have undertaken an undergraduate degree equivalent to an Australian bachelor's degree with a major in physics or related discipline, and at least attained an average of 65% in your program, specifically at the 3rd year level, or have qualifications and experience that the Faculty of Science deems to be equivalent. An alternative entry is at the 2nd year. Bearing in mind this is a 2-year degree, so if you enter at level 1, you complete 2 years full-time. You can, however, enter directly at level 2, in which case the 1st year will be credited to you. In order to enter at level 2, you have to have a 4-year Australian honours degree or equivalent with a major in physics or related discipline. And again, we look for an average of 65% or better in the cognate areas, particularly physics, mathematics, and to a lesser extent computing. There's also a requirement for international students to fulfill English language requirements. And I won't go into the details here, but if you enter into Google, you can search for Monash English language requirements, and that information will be made available. Let me talk briefly about the course structure. In the 1st year, you do coursework and you do a research project. The coursework is broken up into 2 units, which we'll call PHS 4020 and PHS 4021, each worth 12 points. This coursework is undertaken in the 1st semester, in other words, in the 1st half of year 1. In the 2nd half of year 1, in other words, the 2nd semester, you undertake a research project, which is worth 24 points. This is called PHS 4000. Now, I need to emphasize that although you devote your energies in the 2nd semester entirely to the research project, you will actually start the project at the beginning of your MSc, and continue your research while you're doing your coursework. So you'll be assigned a supervisor right at the beginning and a research project, and the project will continue throughout the first year. Now, at the end of the first year, after having completed your coursework and your project and having been assessed, then you're eligible to pass on into the second year of the program. In the second year of the program, the pattern repeats. So you undertake advanced coursework units. These are called PHS 5020 and PHS 5021. These advanced coursework units follow on from first year. They're worth 12 points each, and again you complete this aspect of your coursework in the first half of the second year, in other words in semester 1. You then continue on in the second half of year 2, in other words second semester, to complete your research project, your advanced physics research project. And this combination of the coursework in the year 1 and year 2, together with the project which is undertaken over the full 2 years, leads to the MSc. Let me briefly mention the coursework units. So in year 1 you choose 6 coursework units and you will complete an interim research project. The project will be assessed by examiners and the coursework will be assessed by a combination of exams, tests, orals, essays and other methods of assessment. The 6 coursework units are chosen from a wide range of options. So for example, in physics, quantum mechanics is compulsory, but you choose 6 of these in the first year. And you can see it includes everything from electrodynamics and statistical mechanics through to quantum information theory, quantum field theory, general relativity and cosmology, data analysis and machine learning. So you can see that there's a very extensive range of coursework options in the first year. In the second year, you choose 6 advanced coursework units, and these build on the options that you've chosen in the first year. You then undertake and complete your research project, leading to a major MSc thesis. The coursework units that you choose in the second year are likewise many. You can choose from advanced quantum mechanics, quantum fluids, advanced quantum field theory, statistical field theory, advanced general relativity, condensed matter, and so on. So I think one of the selling points of this MSc is the breadth and depth of coursework that you can choose from, as well as having access to state-of-the-art facilities and researchers who will be your supervisors. Let me talk a little bit about the facilities. So Monash University has got access to extraordinary world-class facilities. Let me just mention a few that you may be using, and I say may because it depends on what research project you undertake. If you undertake a project in gravitational wave physics, you'll access certain facilities. If you undertake a project in synchrotron science or electron microscopy or condensed matter, excuse me, you will access other facilities. So for example, the School of Physics and Astronomy hosts a range of world-class facilities, such as the Australian Research Council Centre of Excellence in Future Low-Energy Electronics Technologies, or an ARC Centre of Excellence in Gravitational Wave Discovery. Also a Centre of Excellence in All-Sky Astrophysics, Astro 3D, the Centre for Atomically Thin Materials, Centre for Electron Microscopy, and the Monash-Warwick Alliance in High-Energy Particle Physics, which is an alliance between Monash University and Warwick University in the UK. But we have far more than this. We have access to the Australian synchrotron, which is opposite Monash University. You have access to international synchrotron facilities in Japan, in Europe, United States. If you choose a project involving experimental particle physics, you'll have access to the Large Hadron Collider at CERN, where we conduct experiments on CMS and LHCb. And if you're conducting cutting-edge research in materials, you'll have access to the Melbourne Centre for Nanofabrication. If you're doing work on gravitational waves, you'll have access to facilities such as LIGO in the United States. And Other facilities include the European Southern Observatory, the ALMA Observatory, the Joint Institute for Nuclear Astrophysics, just to name a few. So I think in summary you can see that we have access to, and you will be provided with access to, a range of facilities. Here's just two simple examples. On the left we have the New Horizons Research Centre, which houses all of the school's research laboratories. Indeed, this facility here will be your home for 2 years because the master's students are co-located within this building. On the right we have the Australian Synchrotron, which is opposite Monash University. And I said, if you are doing work in X-ray optics or synchrotron science or biomedical imaging, you will be able to access that facility. Now, equally important, in fact, in my opinion, probably more important than the facilities, are the actual people. So we have a very wide range of world-class experts in everything from atomic physics and astrophysics, through to X-ray science and zeptoscale physics, which is the scale of the Large Hadron Collider. Short distances meaning high energies. So we have a very wide range of researchers. In fact, we have one of the largest cohorts of fellows involving Laureate Fellows, Australian Research Council Future Fellows, DECRA Fellows, NH and MRC Fellows, and so forth. So we have these world-class facilities complemented by world-class researchers, and you will have a supervisor or supervisors in one of these areas. Finally, let's just talk briefly about career outcomes, which is always of interest to students undertaking the master's program. So let me say that the skills that you acquire in the MSc are highly sought after by employers in a very wide range of areas. So our graduates use their knowledge in managing research facilities, medical imaging, climate modelling, development of scientific instrumentation, R&D development, big data analytics and visualization, the energy sector, science, communication and media, and even as far afield as banking, finance and patent law. Consequently, our graduates find employment in industry, scientific institutes, including universities, hospitals, for example, as medical physicists, government organisations such as the Australian Nuclear Science and Technology Organisation or the Bureau of Meteorology or the Australian Synchrotron, just to name a few, in science, communication and media, or indeed in startup companies. So the skills that you acquire, the research skills and the technical knowledge and communication and other skills you acquire in the MSc position you very well for these industries. And of course, a master's degree from Monash also equips you to proceed to a research doctorate, a PhD. So in summary, there are many reasons that we would invite you to consider Monash as a place to undertake your coursework MSc degree. If you want further information, there are websites, handbook, YouTube and Facebook links that you can access that you can see on this page. And of course, please feel free to contact me or anybody else at the university to make further inquiries. So thank you for giving your time. I hope we'll see you at Monash at some point in the future.